Hey everybody. Today's lesson is going to be on we're going to be using formulas to find the area and the volume and the surface area um, for some different shapes. So just a quick reminder, you should have covered most of this when you were back in middle school, but it's been a while since we've been in middle school. So you do have a formula sheet. Unfortunately, when we take our EOC, they do not give us a formula sheet. So they expect us to have these memorized. So again, this will you'll be able to find this sheet in class. I will give it to you or on Canvas. It should be loaded. But either way, you'll have a copy of this, but you do want to start memorizing these formulas. And again, today's lesson basically is just using them. So going over triangle, rectangle, trapezoid, parallelogram, and circle. So these are the formulas for the area and the circumference. And then when we start talking about our solids, that I can then find the volume and the surface area. So volume is how much something would hold, and the surface area would be if you had to wrap that thing as a gift. How much paper would you have to use? Or you had to paint it, how much paint would you have to use? You want to cover the whole outside surface. Volume is how much will it hold. Surface area is how much to cover the whole thing. And again, these are rectangular, so it has a rectangle base as a prism. You can have just general prisms. That's just a generic kind of formula. And the capital B stands for the area of its base, because you'll notice that the bases are changing here. This one has a trapezoid for a base, and this one has a triangle for a base. Then you have your cylinders. You have your square pyramids that would have a square at the bottom. You could have again, it would just be the area of the base if they changed that base on you, because you could have a triangle as the base of a pyramid. Um, you could also have a rectangle. So then we also have our cones and our spheres. Okay, so those are the list of formulas that we're going to be using. And again, if you ever see a capital B in a formula, that represents the area of that base. If it's a little b, then it's just the base um, that we'd be talking about. Okay, so then basically what we're going to do in class is just work through some problems so that we can remember how to do these. So I'm going to see if I can make this a little bit bigger. Hopefully you can see that better. So the first thing, you've got to read your directions because you have to know, are they asking you about the area, the volume, or the surface area? You need to know which formula we're using. Then we also have to know what shape we're dealing with. So this shape is a parallelogram. And because that thing is a parallelogram, then the area of a parallelogram is going to be the base times its height. So it's going to be the area of its base times its height. So parallelograms, it's just base times height, like a rectangle, length times width, but we call it base times height, right? And rectangles are parallelograms, so we can think about it that way. So in this case, it's telling you that this line right here is its base is 7.7. And the dotted line right here is saying that that's 4. So we're just going to multiply those two numbers together to get our answer. And because it is an area problem, this would be a meter times a meter, which would be a meter squared for our units. Okay, again, since this is a video, I'm going to just keep going. You can stop, pause me if you need to get caught back up. Second one we're going to talk about today, well, this is a trapezoid. And if you have a trapezoid, then what we need to do for that formula is we need to take the sum of the bases. Okay, so we're going to add these two together and then divide by 2. Y'all, it's the average of the bases times the height. So it's the average of bases times your height. So average of bases, that's going to look like B1 plus B2, and then you're going to have the 1/2 because you have to take the average, right? So here we go. I look at that, and one of my bases is a 0.8 inches, 8/10, and the other is 2 inches. So I'm going to add those two together. That's what we're doing here. Then we would divide by 2 to come up with the average. And then, of course, you do have to multiply that by the height, and the height in this case is the 1.7. So again, thinking about your units, you are adding these. So these just inch and an inch is staying an inch. But an inch times an inch is going to be an inch squared. So put that in your calculator. Again, you can put it in just like that. 1/2 in parentheses. Parenthesis 2 plus 0.8. Close your parenthesis. That's going to tell the calculator to multiply. And then 1.7, and it will give you back that answer. Okay, so we're just using formulas, getting the information from the picture, deciding what do they want me to do. First of all, area, surface area, or volume, and then looking at the diagram, decide if it is a what the shape is, and then decide what formula I can use. Okay, so this next section of this sheet, they're all kind of doing the same basic question, so I'm only going to do one of them because, again, you should have access to this through Canvas. This one's a teeny bit different. This one says find the missing measurement, and it wants me to round my answer to the nearest tenth. Okay, so first of all then, if I look at this problem, it tells me the area. They already worked out the area, but a piece of it's missing. So this is an area problem. This shape right here is a trapezoid. So that's what we just did. We would have to add the bases and divide by 2, or half of the sum of the bases, which is the average of the bases, times the height. So let's just plug all that information in. The area would be equal to 33.1. So 33.1 is going to equal, remember, we're going to add our bases together, x and 7.7, and then we multiply that by 1/2 because it's the average of those bases. Multiply that by the height, which is 5.8. So when we do this, we got a little bit of math that we can do here because we want that x by itself. So I think what I would do is I would multiply both sides by 2. That's going to get rid of this 1/2 part here. So 33.1 is going to be multiplied by 2. Then I've got this 5.8 that if I divide both sides by 5.8, it's just going to leave me with an x plus 7.7. So then if I subtract that 7.7, it's going to leave me with that x by itself. So my x is equal to, again, what did we do? We took our 33.1, we multiplied by 2, we divided by 5.8, and then we subtracted the 7.7. And if you ask your calculator to do that, it will give you an answer about 3.7. And remember, it said round to the nearest tenth, so that's why we did it to the 0.7. And this is an area problem. So my area is inches squared, but what are you trying to find? This little piece right here would just be plain old inches. Okay, the next section deal with the directions are changing. This says find the volume. Volume, how much will it hold? Find the volume of each figure. Keep your answers in terms of pi. So that means you're going to see answers that have pi in them. I'm not going to put pi in my calculator. It does say to write out the formula each time so that we'll remember them. And that's always a good idea, y'all, when we're practicing these things, because the more senses you use, if you actually look at it, write it down, and say it out loud as you're writing it, it's going to help you remember that when you need them later. Okay, so here we go. This is a cone. Well, the area of anything, the volume of anything that comes to a point, whether it's a cone or a pyramid, you got the 1/3 in there. Okay, so it's going to be the area of the base times the height, and then it's 1/3 of that, or divide by 3. So this is a capital B because it's the area of the base. Well, the base of this thing is a circle, and the area for a circle is pi r squared. So this pi r squared, because the radius right here is 5, so pi r squared, the 1/3 drops down, pi r squared is my b, and my h is going to be this 11. And then I put that all in, and it ends up coming out to be 275 pi divided by 3. So if you look at number 9, you can see that it's very similar. The only difference with number 9 is that you are not given a radius, you're given the whole diameter. So because you're given the whole diameter, we're going to have to cut that back and figure out what half of it would be so that we could see what the radius is. So if the diameter divided by 2 is going to equal my radius. It's the same shape. It's still a cone. So it's still 1/3 area of the base times its height. So the area is, or the base is still a circle. So it's still pi r squared. But notice again, that 24 is going to become a 12 because 24 divided by 2 equals 12, which is going to equal my radius. So 1/3 pi 12 squared, pi r squared, times the height, and the height is given right here as 24. So I put that in my calculator and I say 1/3, and then parentheses 12 squared, then parentheses 24, and then I put enter, and it'll multiply that all out for me. And then my answer, I will put the pi back in. And it is a volume. So I don't know that I mentioned that up here, but because it's a volume, you're going to have units that are in the are raised to the third power. They are cubes. Because again, you multiplied your radius squared. So that's an inch times the inch of the height. That's 3 of them. So inch, 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 inch times inch times inch is an inch cubed. Okay, then we have a cylinder. And the formula for a cylinder, see, these are very similar. The only difference is you've shaved off part of it, right? This is a third the size of a cylinder that would have the same base and height. So it would take 3 cones to fill up a cylinder if they had the same height and the same base measurements. The diameters were the same for the height and the base. Then it would literally take 3 cones to fill in that same dimension of your cylinder. So the cylinder is 3 times as big. So it's the same formula without the 1/3. So it's a circle. That's going to be a pi r squared. Radius is 11. So pi 11 squared, and then multiply it by its height, which is 9. And the calculator does all the work. Remember, it said leave it in terms of pi. So we have pi as our answer. And they were feet. So these will be cubed, feet cubed. Well, just like in the cone, how sometimes they give you a diameter, they can do the same thing for a cylinder. Number 10, this is a cylinder, so it's still the area of the base times its height, but we have to be careful because this time they've given us the whole diameter again. So I'm going to have to say if my diameter equals 8, then 8 divided by 2 is going to be the radius. So my radius is actually going to be 4, and that's where that 4 is coming from. So the area of the base is going to be pi r squared. So it's pi times the radius, which is half, 4 squared, times its height, which is 3. And that gives you 48 pi. And they were miles. So this would be miles cubed. All right, so we've talked now about the finding the different area of parallelograms and trapezoids. We've talked about finding volumes of cones and cylinders. So if we continue on, the next shape that we're going to talk about would be, again, still doing volume, but this is a sphere. So the volume of a sphere is 4/3 pi r cubed. This is if it's a sphere, like a orange or a baseball or basketball, right? So it's a ball, a sphere, and the volume formula is 4/3 pi r cubed. So I need the radius. They gave me the radius, it's 8. So literally all I have to say is 8 cubed. Multiply that by 4, divide by 3, or 4/3 in parentheses, times 8 raised to the third power in parentheses, hit enter, and it'll give you 2048 divided by 3. And then remember the pi gets stuck on, and it's a volume. So that's going to be inch to the third, or inches cubed. Well, again, if you know that the diameter is 24, then we're going to have to cut that in half to get the radius. So we're going to be using a 12, not a 24. So it's 4/3 pi 12 cubed because it's radius, not diameter cubed. It's radius cubed. And again, put 4/3 in parentheses in your calculator, put in 12 to the third in parentheses, hit enter, and you'll get this answer. Remember, the pi is part of your answer, and the unit was meters, so it will be meters times meters times meters, meters cubed. That's if it's a sphere. Okay, so we've talked about the volume of cylinders, of cones, of spheres. Now we're going to talk about prisms. Well, prisms, a lot of times if it's a rectangular prism, you've been doing this since middle school also, it's a box. And box is just length times width times height. Okay, I want to remind you though, this is really just the area of the base times the height because the area of the base is your length times width. Right? So the formula really, this capital BH works for just about everything. We just need to remember what is the area of the base. Well, what's its base? Its base in this case is going to be a rectangle. So I have a 5 by 2 as the base. So its length is 5, its width is 2, and its height is 4. And I multiply them all together. Boom, I get 40. And they were miles, so it would be miles cubed. That one's pretty straightforward. Okay, and there's some more examples here if you need them. Well, if we are doing the volume of a prism and it actually changes and it doesn't have a rectangle at the bottom, it has a triangle as the bottom, then that volume is still going to be the capital B over H. It's just you're no longer dealing with a rectangle, you're dealing with a triangle. So the area of the base here is going to be a triangle. Okay, the base is a triangle. And the area of a triangle is going to be 1/2 little bh. Its base times its height. So here's my triangle. On the bottom, it has a 3 here. It has a 4 going up the side here, and it has a 5 as its hypotenuse. Well, I don't know if y'all can see there's a little 90-degree angle right there. That 90-degree angle will always mark what is the base and the height. So if you can find that 90-degree angle, that L that forms, those are the two numbers you're going to use for your BH of your triangle. So it's a 3 times a 4, and then it's 1/2 3 times 4. And then the height of this thing is 1. So we just multiply all of that together, and we get 1/2 of 12, or 6. And they were yards, so it would be yards cubed. Numbers 21 and 20 and 21 come to a point. They're pyramids, just like our cones. They're going to have that when they come to a point, they're going to be a 1/3 area of the base times height. So you've got to decide what's the base again. It's a triangle. This triangle has a 90-degree angle in there. So there's your 90-degree angle. So it's a 6 and an 8 that you're going to use for the 1/2 base times height for your triangle is going to be 1/2 your base times your height, 6 times 8. So it's 1/3 from the formula. 1/2 8 times 6 for the area of the base. And then the height of this thing actually comes from the point straight down, making a 90-degree angle. So that's its altitude. So its height is going to be 10. And you multiply all those together and you get 80. And since they were meters, it will be meters cubed. Okay, so the only difference between this pyramid and number 21, its base is different. So we had to find the area of a triangle for this one. But for number 21, you've got a square base. It's the same formula, 1/3 because it comes to a point, area of the base times the height. Well, looking at the base of this, it's a square. So the area of a square is length times width, right? 3 times 3. So it's 1/3. Area of the base is 3 times 3. And coming straight down again for your height is a 4. So you multiply all those together and I get a 12 inches squared. So that's the volume of prisms, doesn't matter what its base is, right? Pyramids, which is a 1/3 of those, base times height, area of the base times height. So your area of any prism is area of the base times height. Pyramids come to a point, so it's a third area of the base times height. Your volume for a sphere, that was 4/3 pi r cubed. And then we talked about our cylinders again, and our cylinders are very similar. That's just going to be, again, remember how your volume for your pyramid was capital BH? Well, your volume for your cylinder is capital BH. And the ones that come to, right, capital BH right here. The ones that come to a point are just going to be 1/3 BH. So your cylinders and your cones are just like your prisms and your pyramids. Your cylinders and your cylinders and your prisms, right? Your boxes and your cans are going to be capital BH, area of the base times height. Your pointed ones, your cones and your pyramids, are going to be a third of that capital BH, a third of the area of the base times the height. All right, so then the last little bit that we're going to do on this sheet talks about surface area. And so surface area, if you have a sphere, surface area has its own little formula for a sphere, and it's 4 pi r squared. Okay, the 4/3 pi r cubed is for the volume, but 4 pi r squared is for the outside surface of a sphere. So you still do need to know what the radius is. So I still would have to cut that 20 in half to get 10, but then it's 4 times pi times 10 squared, which is 400 pi, and they were yards, so yards squared because it's area. We're going back to square units. If they give you the actual radius, this one's even easier. You literally just say 4 pi times that radius. So 4 times pi times 9 squared, and they were miles, so miles squared. Surface area of a sphere is 4 pi r squared. Okay, then we have a box. Well, and you can think about if you're wrapping a box, you need to, or painting a box, you've got to know what is the area of all of the sides. Well, if it's a box, you have two of the bases, right? So we have a top and a bottom that are the same. We have a left and a right that are the same, and well, how would I say that? A front and a back that are the same. So if this is a box, right? So I have 2 length times width here, and then I have 2 with a height times a width, and then I have 2 with a height times a length. So I just grab those numbers. So this top part right here, that's a 2 and a 3. So I have this 2 and 3, and down here on the bottom is the exact same thing. So there's 2 of those that when I multiply 2 times 3. So that's where this comes from. This is I would call that maybe the top and the bottom of my box. Okay, then I have an 11 with a 3. So that's going to be this long piece right here and that part. So I'm talking about this side over here and this side over here. And there's 2 of those. So I have 2 of the 11 times 3s. And then I also have a 2 on this side and an 11 that's going to go up. So that's going to be the like the top part of the box right here and underneath the bottom part of the box. So I have 2 of the 2 times 11s. And then we just go ahead and multiply all those pieces up and add up all those different parts. Or you can literally put it in your calculator just like that. 2 times 2 times 3 plus 2 times 11 times 3 plus 2 times 2 times 11. If you put that in, and then you get your 122, and they were kilometers, so it'll be kilometers squared. So the only other last part that we have to talk about for volumes is that sometimes what they're going to do is they give us these compound shapes. So they will give you a shape that has like 2 things all together. So this one says find the volume of each figure, round the answer to the to 2 decimal places. And this actually is telling us to use 3.14 So these answers are going to be off a little bit. You'll notice that they don't have a pi in them, and it's because they told me to use the 3.14. That makes a huge difference. Okay, whether pi is there or whether you're rounding to 3.14. But what I want to just show you really is what I need your brain to kind of think through when we're solving these is if you wanted to find the volume of these, then what you could do is figure out what's the volume of one part of it and add to it the volume of the other. So this part, if you know that you have, if I'm working through this problem, let's see, I've got a 16 times 4 times 6. Well, that's my 16 times my 4 times my 6. So that's going to tell me what the volume of this whole big bottom part is right here. Okay, then notice that we on the top here are going to say that you've got from this point right here to this point right here, they're telling you that that's 12. So we have this shape on the top, which is going to be a prism again, right? And that looks like it's going to be a rectangular prism. So then this is going to have this 12 and a 9. And then the height of that, where are we getting our 4 from? Oh, the 4 here. If the 4 is down here, then I've got a 4 would be for this part right here. Okay, so I'm going to say 1/2 my 12 times my 19. I'm sorry, my 1/2 the 12 times the 9. So the 12 times the 9 times the 4. That part right there is going to be added to my base of this, which is just the box, which is 16 times 4 times 6. And then I just add those two together, and that's going to give me my 600 for my inches cubed. Okay, so again, when I just kind of look through these, not exactly sure how much of this you're going to be tested on, but I just want you to be aware of it, that if they do give you some odd shapes, it's okay. Just break them down into the parts that you know and solve them that way. So like this piece right here, that top part and this bottom part would come together and make a circle. So we could find the volume of, I'm sorry, a sphere. So we could find the volume of the sphere that has a radius of 6. And then you also then have this piece right here on the inside, which would be a cylinder. So we'll just do our sphere with our cylinder and add them together. And then this one for number 3, it's just a normal box on the bottom. And then this is half of a sphere. So notice we use our formula for the sphere, but then we just cut it in half because you only have you only have half of it. And then again, we just plug those numbers in and combine them together. So you're finding, looking at your shapes, breaking your shapes down into the two different solids that you know how to find the information for. So again, this guy right here is going to be one of those triangular prisms, just like we had up at the top. So that's going to be your base is a triangle. So that's going to be that 1/2, right, for this triangle. 1/2, 14 times 5. And then I'm going to multiply that by its height, which is 9. Because if it's 9 down here, then I'm 9 down here, right? This triangle is the same thing as the one that we did back up here. This was a triangular prism. This one is going to be a triangular prism also. I got confused by prism and pyramid there, but this is a prism. Okay, so your area of the base of that thing is a triangle. So I multiplied the area of the base times its height, and then I take again, the volume of just a normal pyramid, just a box, normal prism, which is your box, and add those together. Sorry, I'm getting my prisms and pyramids confused. My tongue's getting tongue-tied. And the last one here for my prisms, again, you got a box on top of a box, figure out the volumes and add them together. And last but not least, we've talked about this before, when you have half of a sphere, you're going to take half of the sphere formula. And then from here, you're going to figure out what this bottom piece is, which is just a cone. So you find the volume of your cone, which is 1/3 the area of the base times its height, and we add those two together. Okay, I hope that helped. And really, it's just a matter of using the different formulas. And the hardest part, y'all, is that you're going to have to go back and memorize these formulas. So as you're writing them down, make sure that you're as you're using them, make sure that you're writing them down. You're talking about them, you're looking them over so that we have these things memorized. All right, have a great day.